All right, guys, I'm going to get a couple more sample problems out to you guys today. We've answered a few questions here and there, and it's kind of given me a good idea on where everybody's at and what some of the gray areas are. So before we start combining what we're doing today with the addition that we did the other day and solving, in theory, three vector problems just to get one resulting vector with all the trig involved in that, I'll do a couple of these smaller problems with you. And just imagine we're all together in the same room doing these up on the board for old time's sake. So this is real similar to one of the ones you guys got in your homework. We got a magnitude of 13 here and a direction of 310, and what we're trying to find is the coordinates. So let's look at what kind of math is going to be involved to get that. Now, first thing, it's really hard to solve any of these without drawing a sketch of a graph. And a lot of times when you're drawing that, it can kind of just be a generic drawing. It doesn't have to be to scale, just to help you understand where your sides of the triangle are. So when you get your opposite or adjacent, and what is the relationship of that to your angle that you're solving for. So it's really hard to solve these without drawing something in here and getting a little diagram. If you guys are good enough and don't need to, then just make sure you follow directions if it says to graph it or not. If it doesn't, then don't worry about it. But I can't see a lot of people solving these without graphing them, just to get an idea on the orientation of your triangle for your trig. So we have the magnitude here. We know it's going to be 13, and we know the direction is 310 degrees. So knowing that this overall is 360 degrees, with that 310, I know I'm probably going to be somewhere down in this range. And what we know as well is that each of these quadrants are 90 degrees. You can even draw something like this in there to remind you our little 90-degree symbol from trig. So if I got 90, 90, 90, then I know I got 270 degrees there. So if I take my 310 and subtract the 270, I'm going to get 40 degrees. So I'm going to travel all the way 90, 90, 90, and then I'm going to travel another 40 degrees before I get to my vector. So there's a visual representation of what we're doing, but you should be able to see also just exactly where you're going to be based on that 310. I mean, you should know you're past 270. You're going to be down here in the fourth quadrant. This is the fourth quadrant down here. And one other observation before I do any math is that to build a triangle in this direction, I'm going to have a negative y value, but I'm also going to have a positive x value. So before I do any math, I'm just going to make those two observations just so when we get too deep into the triangle, we don't forget the big picture here exactly. So just with those observations in mind, let's go ahead and look at what the next step we can do. So we have our direction of 310, and we know that that leaves us 40 degrees past the 90-degree mark here on the negative y-axis. So this is our angle, 40. Not over here. That would be an error you don't want to make. Now with that angle, I know I have a magnitude of 13. And remember, the magnitude is really the hypotenuse of a right triangle. So in this specific orientation, I'm just going to draw my little not to scale graph here, my little not to scale vector on my XY chart, just a reference triangle so I know I'm putting the right values where they belong. So I know I have an angle of 40, and then I have a hypotenuse of 13. And what I'm going to want to do, so I can find my vector coordinates, is find out the sides of this triangle. So I'm going to want to find out my opposite to my 40 degrees and my adjacent to my 40 degrees. I have the hypotenuse. So with our little mnemonic, I know that if I have the angle 40 degrees and a hypotenuse, and say I want the opposite first, so let's say I have sine of 40 degrees equals the opposite over 13, my hypotenuse. So multiply both sides by 13. And now I have 13 sine 40 equals my opposite. So that's going to be what I can punch in right from there to find my opposite side of my triangle. So 13 sine 40 gives me the opposite side of 8.356. So that's a length. That's not an angle, right? So that's going to be this side over here. So the opposite is 8.356. Now I can do the exact same thing with cosine, right? Because then I'm just going to be using the adjacent and my hypotenuse. So this would be the exact same math, but instead of sine, I would have cosine. So I could write all this out, but just for the save time in the video, I'm just going to write 13 times cosine 40 equals my adjacent value. Because I'd be doing the same cancellation here, right? All I really changed is the sine or cosine, whether I'm solving for the opposite or the adjacent. So with that, I'm going to have 13 cosine 40, and that gives me an adjacent of 9.959. So let me write that here on my chart so it reminds me that that's the side that I have. That's the angle. If you want to redraw your triangle somewhere else and put your values in there, you know, that's fine too, but don't lose perspective on where it's oriented on your chart, because 8.356 and the 9.59 could easily get mixed up if you lost your perspective on what they were to your 40-degree angle. So I'm going to put 9.959. Now this is just a picture of the sides of a triangle. Now I need to apply some critical thinking to say, what are my coordinates here at my endpoint? So I know that I'm traveling this side of the triangle down in the negative direction. Again, it's not to scale. I'm traveling 9.959 down, and I'm traveling over, whether I'm down here or up here, 8.356. So which one of these is my x and which one is my y? Well, x is going to be traveling in this direction, which takes me to my 8.356. And the 9.59 is traveling down in this direction, which is in the negative y direction. So my x and my y is negative 9.959. So if this doesn't make sense on why the x value is positive and the y value is negative, it has to do with what quadrant it's in. Anything in this quadrant, you're going to be traveling in the positive direction on the x, and you're going to be traveling in the negative direction on the y. If we're in the third quadrant over here, both numbers are going to be negative because I'm traveling in those directions. And again, everything's going to be positive if I'm up here. So don't lose your perspective. So it's got a little bit messy. It's kind of hard to write on the tablet here, but I think you guys got the gist of it. And the few people that have been sending in some work to get checked, for the most part, it's all been correct. So this is for the first assignment that we're doing. If you're doing something like this, you're on the right track. I'll do a couple more and I'll get those out as well. So keep up the good work.